Hello viewers, welcome to our GIRI classes. Today's video lecture is all about your operator algebra and that too part 2. If you are new to this channel, just go to the part 1 section and you will find very interesting questions of CSR NET chemical science. So let's coming to the point. Now when you have the question like Hermitian conjugate of d by dx, you have to find out what is the answer, right? So it is represented like this. It's known as dragger. It is known as dragger, read as dragger, and the value is minus d by dx. The value is minus d by dx. That means answer is option B. So there is also typical, you can say there is derivation there, but we don't focus on derivation because we are just focusing on solving previous year question like CSR Chemical Science 2011, right? So first of all, you have to remember this concept, right? That is a dragger. If a dragger is equal to a, that is a is here, this operator is Hermitian, and if a dragger is equal to negative of your operator, that is a is anti-Hermitian. Okay, anti-Hermitian. So basically what is the objective of ALGEBRA classes? The objective is very clear. So if you find difficulties in solving these numericals, just follow my lectures and just follow what I am saying. That's it. You don't have to do anything. Just follow my lectures and you will easily solve all the questions, right? And if you have this Hermitian operator and if you multiply with I, right? I, you know that I, there is an imaginary part. This is represented like this, root over minus 1. So if you multiply I with your Hermitian operator, then it will be converted to anti-Hermitian operator. Similarly, if you have anti-Hermitian operator, if you multiply with I, then it will be converted into Hermitian operator. There is derivation there, but we don't focus on derivations, right? And suppose if your a dragger not equal to a, if your a dragger not equal to negative of your operator, that means a is neither Hermitian nor anti-Hermitian. Here this is Hermitian, here this is Hermitian and anti-Hermitian condition. If not equal, then neither Hermitian nor anti-Hermitian. It's a very important point, right? And you have to remember this is conjugate, right? This is conjugate. That means your I is a conjugate. If you find out the conjugate of I, the value will be minus I. You remember e to the power ikx or e to the power ix, right? The conjugate part, it's represented like this, e to the power minus ix, e to the power minus ikx, right? So therefore d by dx, the dragger is equal to minus d by dx, because d by dx operator is anti-Hermitian. Let's find out how many shortcuts we can apply for this Hermitian and anti-Hermitian part. First, you have to remember all the operators given in the postulates of quantum mechanics. I already discussed this in part 1. The observables and the corresponding operators are like this: positions, linear momentum, kinetic energy, potential energy, Hermitian operator, Hamiltonian operator. Actually this is Hamiltonian operator, not Hermitian. This is Hamiltonian operator. Sorry, just ignore it. Hamiltonian operator. Basically this is an energy operator. So we are just focusing on two energy operators. That means this is a combination of this is known as energy operator, that is total energy operator, that is your kx and your vx, right? Potential energy and kinetic energy, and angular momentum, right? Angular momentum, this one. Okay, this is orbital angular momentum, this is linear angular momentum, and already we discussed some numericals related to your spin, right? Spin angular momentum, right? Spin angular momentum, that was Sx. So coming to the point, our objective, that is postulates of quantum mechanics are essentially Hermitian. That means x, px, kx, vx, h, lx, these all are Hermitian operator. Remember, these all are Hermitian operator. Keep it in your mind, may come in an examination, right? So now find out how many anti-Hermitian operators. Just we need to remember, that is d by dx and minus d by dx. Yes, d by dx and minus d by dx anti-Hermitian. Anti-Hermitian means if you find out d by dx, the dragger, it will be a negative value. Similarly, negative value will be negative of this value, that means a positive value. That means dy dx minus dy dx, and minus dy dx dragger is equal to dy dx, right? So if you multiply with I with this anti-Hermitian operator, this anti-Hermitian operator, this anti-Hermitian operator, the value itself the same, because I dy dx is Hermitian operator. That means the dragger of this one, will be same, right? Because a cap dragger must be a cap for Hermitian condition. But the question is, this is anti-Hermitian operator, that means its dragger is equal to minus d by dx, because anti-Hermitian condition, a cap dragger is equal to minus a, right? So no need to go into that detail solution, just focus on that. I into anti-Hermitian, Hermitian, I into minus this minus of dy dx, that is your anti-Hermitian operator, then the result will be Hermitian operator. And d square by dx square is your Hermitian operator. Keep it in mind. D by dx is anti-Hermitian, minus d by dx anti-Hermitian, but d square by dx square Hermitian operator. Now question number 2. Identify among which will be your not Hermitian. Its question is not anti-Hermitian, question is not Hermitian, not Hermitian, right? Not Hermitian. Not Hermitian, that doesn't mean that you will find out neither Hermitian nor anti-Hermitian, right? Not Hermitian, right? So you will find among which the options which will be not Hermitian, right? So you know that x is Hermitian, just cancel it, not option D is wrong. dy dx square, it's a Hermitian operator, cancel it. And I d square by dx square, you know that this is your Hermitian operator, and it is I into Hermitian operator, that means the result will be anti-Hermitian operator. That means it is the answer, right? And h by 2 pi I dy dx, check it this out, okay? H by 2 pi I dy dx, right? So I already told you, when you will put the dragger, that means you have to make conjugate part if you have I, and these all are constant, like h is equal to Planck's constant, 2 is constant, pi is equal to 3.14, right? 6.624, right? These are 6.626, right? Into 10 to the minus 34 joule second, and all these things, these are Planck's constant. So these are constants. So all these are constant, but this is imaginary part. Imaginary part having conjugate, you have to do with this conjugate of this imaginary part, and you have to put the dragger of the operator. Clear? Now find out this one. So what will happen there? I will be minus I, that means h by 2 pi I, it will be like this, minus h by 2 pi I, because this is like this, h by 2 pi minus I, it can be printed like this, minus h by 2 pi I, or it can be printed like this, minus h by 2 pi I. Very easy, it's simple, very small level of mathematics. Just you have to apply your common sense, that means this one. And you know that d by dx is a anti-Hermitian operator, that means a cap dragger is equal to minus a cap, dragger is equal to minus a cap. So what will be the result? This is minus h by 2 pi I, and this is minus d by dx. The minus is equal to plus, that means h by 2 pi d by dx. That means initially your operator was like this, h by 2 pi d by dx, and its dragger is same. Its dragger is same as the initial operator. That means a cap dragger is equal to a cap. That means it's a Hermitian operator. The answer is this one. This is not Hermitian. This is not Hermitian, or simply say this is anti-Hermitian. All these are Hermitian operator. This is Hermitian. Option C Hermitian, and option D also Hermitian. Clear? Very easy. Now question is like this. Question number 3. Little bit lengthy, but just focus on the basics, and you will get the answers very quickly. Okay, just be patient and just be focused, right? And use your common sense. This is AB, this is ABA, this is I, AB, and this is A square B. You know that this is written like this. This is AB, that means commutator of A with B. It is written like this, right? AB minus BA. AB, first AB, then BA, right? So it is written like this, and multiply with I. You have to find out what is the result or what is the answer. But before that you have to remember this formula, that is a cap b cap whole dragger. Then you have to individually you have to do like this, b cap and a cap, b cap a cap dragger both case, right? And if this is plus has nothing to do with this dragger constant, they are individually, they can be separated, this plus symbol, because in this case point number 2 that was multiplied, and the dragger constant says you move from right to left, right to left, individual dragger, then multiply with this. And if you have constant, any constant like h by 2 pi, not an imaginary part, but it is as a combo, it is represented in your C part, that is your constant part, and give your conjugate symbol there. And if you have I, then make it to I2 minus I. If you have constant, your conjugate will be same as constant, because imaginary part conjugate will happen, your result will happen. Okay, so this is like this. Okay, conjugate part and this dragger of that operator. And if you have 3 operators and you have to put the dragger and both are in multiplication state, and you know that you will proceed from right to left, that is C cap, B cap and A cap dragger consecutively, right? And if you have addition, so you can simply individually you can take. And if you have A cap dragger whole to the power n, you can do like this. Suppose you have to find out drag like this, a square dragger. So you find out first a square a dragger first, and what will be the result, then they do just square, very easy. If you are -2, suppose this is a to the power -2 dragger, simply do this a dragger to the power -2, just nothing to do with that. Okay, or you simply do that, calculate this one and put a dragger. So it's better not to make it complicated, just find out the answer and then square it. Okay, clear? Let's come to the point. And the given question was like this. So the given question was like this. So you have a cap and b cap, both are Hermitian. That means a cap dragger is equal to a cap, b cap dragger is equal to b cap. First you have to check a b both are in multiplication state, is it Hermitian or not? That means if a cap dragger is equal to a b cap, then it will be Hermitian, and my answer is not Hermitian. Check it out. That means you will proceed from right to left, that is b cap dragger, a cap dragger, and you know that b cap dragger is equal to b cap and a cap dragger is equal to a cap. That means a cap b cap dragger, your answer is b cap a cap. But our expectation was a cap b cap dragger must be a cap b cap for Hermitian condition. That means a cap b cap not Hermitian. Clear? Don't get confused. Okay. A cap b cap a cap whole dragger, then it will be right to left, that is a cap dragger, b cap dragger and a cap dragger. And you know that a cap dragger is equal to a cap, b cap dragger is equal to b cap, and a cap dragger similarly a cap, because a cap and b cap are Hermitian operator. That is a cap b cap dragger, our expectation is same, a cap b cap a cap. Result from where we got the answer, that is a cap b cap is Hermitian. One Hermitian part. Okay, one Hermitian part. Find out this question. All 4, only 2, only 3, only 1. That means you will find out 1, 3, 2, 4. Right? 1, 3, 2, 4. So you have to check number of Hermitian operators in those options. Now you will find out I, A, B dragger, whole dragger. That means this is imaginary part, make a conjugate here, and you have to open this operation, that is your commutator operation, that is AB minus BA whole dragger. Individual will take dragger, individual will take dragger. So what happens? AB dragger and BA dragger, this is a negative symbol there. Okay, AB, that means AB, what happens? AB dragger, that means AB dragger right to left. It looks lengthy, but when you practice it, it will not be lengthy for you. It's just fun for you, right? That means B cap dragger and A cap dragger. B cap dragger is B cap and A cap dragger is A cap. Similarly, this part over, and that is your answer is B cap A cap. And now find out B cap A cap whole dragger. B cap A cap whole dragger, that means multiplication, and you proceed from right to left. This is A cap dragger, and this is B cap dragger. A cap dragger is A cap and B cap dragger is B cap. That means B A cap dragger is equal to A B. B A cap dragger is equal to A B. This is, and negative symbol was already there. So what do you find? You found minus I B cap A cap minus A cap B cap. So result is minus I B cap A cap commutator, that is represented like this square bracket. But interesting fact is that you have to find out in terms of A B. So if you have option like this, and multiply with I, don't get confused. That is minus I B A means same as this one. Don't get confused. Okay, just use common sense there. That means it can be represented like this: A cap B cap, A cap B cap, and I was there. So that means I A cap B cap, I A cap B cap. Clear? That means I A cap B cap is equal to I A cap B cap, I A cap B cap whole bracket is equal to I A cap B cap. That means it's a Hermitian operator. Clear this part? That means we got two answers for Hermitian condition. Now this is A square B dragger. A square B dragger. Right? Starting from right to left, that is B cap dragger and A square dragger. I told you already, if this is square, find out individual first. That means B cap dragger is called B cap because B cap is Hermitian, and A cap dragger square, and A cap is equal to A, because you already know that it was given in the question that it was a Hermitian operator. That means A cap square. That means the answer is B cap A cap square. But your expectation was A cap square B must be A cap square B cap. B cap missing here. If you find in case of your questions, if this is missing, that doesn't mean that you will have to worry for that why it is not given. Just simply it is represented as this operator. So that means A square B dragger must be A square B for Hermitian condition, but it's having B A square. That is not Hermitian. How many Hermitian operators you find? These two. The option is second, right? This is the part, that is A cap B cap, and that next is I A B. So you have two Hermitian operators. Coming to the next point, if you have to find out if operator A is equal to minus d by dx plus x, then A is Hermitian, A is anti-Hermitian, then A cap dragger, you have to find out is it Hermitian or not. A cap dragger is anti-Hermitian or not. This is 2011 question, CSR chemical science, right? That means your A is equal to minus d by dx plus x, and you already know d by dx dragger is equal to minus d by dx. Yes, and minus d by dx dragger is equal to d by dx. So it's result is d by dx, and this x, you know that this is position, and all the quantum mechanics operators are already Hermitian operator. This is x, that is d by dx plus x, d by dx plus x. Now find out, is it in this form A cap is equal to B, A cap dragger is equal to A cap, or A cap dragger is equal to minus A cap, right? So if I represent like this, d by dx plus x, it is obviously not equal to minus d by dx plus x. That means it's not a Hermitian operator, right? Now check, is it an anti-Hermitian or not? Just check it, right? This is your result, d by dx plus x. This is d by dx plus x. Is it minus of this value? Minus of this value or not? See this one. This is minus of this value, because you will find out is it A cap dragger is equal to minus A cap or not. Got this point? That means your value, this value, is it the negative of this value? So find out negative of minus d by dx plus x. The value is equal to d by dx minus x. I was mistakenly left this negative symbol. So this is d by dx minus x, right? That is, if the negative value of this, that means if the value would have been like this, then you can say this is anti-Hermitian. But this is not a Hermitian, this is not anti-Hermitian. Because of this result, this is neither the negative of this one or equal to this one. Got this point? This A cap dragger. Clear? Now coming to the point, A cap dragger. See this one. It can be complicated, it can be easier. Just choose as your heart says, right? But I just suggest you just try to make it short as much as possible using your common sense. This is a cap dragger. As I told you, a cap, this is a cap dragon. Suppose this is a cap, this is b cap. That means you will find your operation from right to left. This is a cap dragger, and this is a cap dragger. And you know that a cap dragger is equal to a cap and this normal a cap dragger. That means a cap dragger, this values dragger is same. That means a cap is equal to a cap dragger is equal to a cap. That means this is a Hermitian operator. Okay. So if you want to find out that lengthy method, just see this one. This is minus dy dx plus x. This is dy dx. This is a cap dragger. See. So what you have to do? So you see here, this minus dy dx plus x, right? This minus dy dx plus x. This is this value, and this a cap dragger is this one. A cap dragger is this one, and this is this value. Okay. So you will find the dragger of this whole, this value and this value, this value and this value, the dragger of this whole. That means a cap, b cap, dragger. What do you have to do? B cap dragger and a cap dragger. So that means this dragger and this dragger. Just before opening of this bracket, find out just the individual part. First the focus on this formula, and then you will find out the individual part. Now this ready for the individual part. The individual part like this, dy dx dragger plus x dragger, and you know that dy dx minus dy dx, this is x. So the result is this one. And similarly minus dy dx plus x, individual part will be like this, right? Minus dy dx plus x. This is minus dy dx dragger and x dragger. The result is dy dx plus x. Clear this part? That means you will get dy dx plus x. What was initially your value? Minus dy dx plus x, and dy dx dragger is equal to minus dy dx plus x multiply with dy dx plus x. That means your a cap dragger is equal to a cap. That is Hermitian operator. Do you like to choose this method or this method? Obviously this method. So answer is your C. Answer is your C. A cap dragger is Hermitian. And don't check this one, right? Nothing is to put your extra mind, because you are finding a cap dragger is Hermitian. Then why you should go for checking this anti-Hermitian? Already this is Hermitian, same value, right? So next, coming to the point. This is for today's class, and I hope that you are enjoying this video lecture series. I am new to this channel, it's okay. So it's doesn't matter, just you have to learn what I am telling you, because I am a professionally trained person for this examination. So like, share and subscribe this channel. So give your feedback, and if you are new to this channel, just go back and see the part 1. So thank you very much for giving your valuable time and watching ALGEBRA classes. Thank you very much.